From Equifax data to executive Power BI dashboards in higher education. Higher education institutions collect enormous amounts of information about students. We know where students enroll, what they study, whether they transfer, and whether they graduate. But there is another question that is becoming increasingly important. What happens after graduation? Do our graduates find employment? What are their financial outcomes? Do outcomes improve over time? Which academic programs produce the strongest results? Where do graduates go after leaving college? And ultimately, are students receiving a meaningful return on their investment in higher education? These are exactly the kinds of questions that external outcomes data, including Equifax data, can help institutions explore, but collecting the data is only the beginning. The real challenge is transforming that data into information that presidents, provosts, deans, institutional researchers, enrollment leaders, career services professionals, and other decision-makers can actually use. In this video, we are going to show you how we would design an enterprise Power BI analytics solution for Equifax graduate outcomes data in higher education. And most importantly, we'll walk through the dashboards that can turn that data into actionable institutional intelligence. What is Equifax data in higher education? When people hear the name Equifax, they often immediately think about credit reporting. But Equifax also provides data and analytical solutions that can be useful for understanding longer-term outcomes associated with higher education. The key idea is simple. An institution already has extensive academic information about its students: institution, college, program, major, degree, graduation term, and student characteristics. Equifax-related outcome data can potentially add another dimension to that picture, such as financial, mobility, geographic, debt, and other post-college outcome information, depending on the specific data product and agreement. When these sources are combined appropriately, we can move from asking, how many students graduated, to asking, what happened to those students after they graduated? And that is a major shift in institutional analytics. What data could be available? The exact data elements depend on the Equifax product and the institution's agreement. For our analytics architecture, however, we can think about several broad categories. We may have graduate outcome information related to employment or financial outcomes. We may have income or salary-related measures. We may have geographic information that helps us understand where graduates live or work. There may also be longitudinal information that allows us to study outcomes several years after graduation. And, depending on the available data sources, we may be able to analyze employers, industries, occupations, debt, financial milestones, or economic mobility. The most powerful approach is to combine those external outcomes with institutional data. Imagine the analytical chain: student, major, degree, graduation, post-graduation outcome, location, financial outcome. Now, we're no longer looking at isolated data points. We're looking at the student-to-career and student-to-economic outcome journey. Start with the audience. Before creating a single Power BI visual, we need to answer one question: who is going to use this information? This is critical because different audiences ask completely different questions. We identify audiences ranging from the chancellor and board through presidents, provosts, deans, department chairs, enrollment management, career services, and the public. A chancellor or board may ask, are graduate outcomes improving? A president may ask, which colleges and programs produce the strongest outcomes? A provost may want to know which majors may need attention. A dean may ask, how does my college compare with its peers? Enrollment management may be interested in programs that both attract students and lead to strong outcomes. Career services may want to identify areas where students need additional support, and prospective students and families may simply want to know what happens to graduates from this program. That's why we would not try to squeeze everything into one enormous dashboard. One dashboard cannot effectively serve every audience. Instead, we recommend building a multi-page executive analytics application. Now, let's look at what that application could contain. Dashboard 1. Executive Overview. Dashboard, we begin with the executive overview. This should be the landing page. Think of this as the dashboard that a president or senior executive could understand within 30 seconds. Across the top, we could display the most important KPIs. For example, employment rate, median salary, average salary, number of graduates, number employed. Continuing education, in-state employment rate, out-of-state employment rate, median time to employment. And when historical information is available, salary growth. These measures are the core of the executive landing page. The objective here is not detail, it is situational awareness. An executive should immediately understand, where are we? Are outcomes strong? Are they improving? And where should we investigate next? From this page, every KPI can become an entry point into deeper analysis. Dashboard 2. Geographic Dashboard. Next is one of my favorite pages, the Geographic Dashboard Higher. Education outcomes have a strong geographic dimension. Are graduates remaining in Georgia? Are they concentrated around Atlanta? How many move to other states? Are there differences in outcomes between regions? Power BI gives us several excellent visualization options here: filled maps, bubble maps, and heat maps. We recommend analyzing graduates by state and county along with salary, employment rate, and, where available, employer information. Users should also be able to filter this page by institution, college, degree, major, and graduation year. Imagine selecting one institution and immediately seeing where its graduates are concentrated, then select computer science. The map changes. Select nursing. It changes again. This allows institutional leaders to see not only whether graduates are successful, but also where that success is occurring. Dashboard 3. Salary Analysis. We come to a dashboard that will attract a lot of attention, the salary dashboard. But there is an important analytical principle here. We should never rely on the average alone. Suppose one program has a few extremely high earners. The average salary could look excellent, even though most graduates earn considerably less. That's why we recommend using a salary histogram, box plot, and percentiles, not simply a single average. We would prominently display median mean, 25th percentile, 75th percentile, 90th percentile, and potentially maximum salary where appropriate. Then allow users to break those results down by institution, CIP degree, and authorized student group characteristics. This changes the conversation from what is the average salary to what does the salary distribution actually look like? That's a much more meaningful question. Dashboard 4. Employment Outcomes. Dashboard, the next page is the Employment Dashboard. Here, we're interested in outcome status, depending on the available source data and institutional definitions. Categories might include employed, not found, continuing education, military, and unknown. But the real power comes from adding time. Instead of showing only the current employment rate, display a trend. The employment section of the proposed architecture explicitly combines status with trend analysis. Now, leadership can answer a much more strategic question: are graduate employment outcomes actually improving? Dashboard 5. Industry Dashboard. If industry classifications such as NAICS are available, the next page becomes the Industry Dashboard. Here we can answer, where are our graduates actually going? Healthcare, finance, technology, government, manufacturing, professional services? Instead of just knowing that graduates found jobs, leadership can understand which sectors are absorbing the institution's talent. This proposes precisely this kind of top industry analysis. That information can support academic planning, employer partnerships, workforce development initiatives, and conversations with state policymakers. Dashboard 6. Employer Dashboard. If employer-level information is available, we would create a dedicated employer dashboard. The page could identify the organizations hiring the largest numbers of graduates. A. Tree Map could provide an immediate visual impression of employer concentration, a ranked table could provide precise counts, and a searchable employer list would allow users to investigate individual organizations. These are the visual patterns proposed in the dashboard design. This becomes especially valuable for career services. Instead of saying, "Our graduates are finding jobs," we can begin asking, "Which employers consistently hire our graduates? From which programs? And how are those?" Patterns changing? That can directly inform employer engagement strategies. Dashboard 7. Occupation. Dashboard industry tells us where graduates work. Occupation tells us what they do. If SOC or equivalent occupation information is available, we can create an occupation dashboard. Software developer, registered nurse. Teacher, financial analyst. Accountant, project manager. These are examples included in the proposed design. Now imagine connecting this to academic programs. Select computer, science. Which occupations appear? Select finance. What changes? Select psychology. Where do those graduates actually go? This starts connecting academic programs to real career pathways. Dashboard 8. Program outcomes. Now, we arrive at what may be the most important dashboard for academic leadership. The Program Outcomes Dashboard. This is probably the dashboard most deans will want. The navigation can follow the academic hierarchy: college, major, degree. For each program, display the core outcome metrics: employment rate, median salary, average salary, graduate count, and when available, top employers and top industries. Imagine a dean selecting one program and immediately seeing its entire outcome profile, then switching to another program or another graduation cohort. Now the dashboard becomes an academic planning instrument. The question isn't simply how many students graduated. It becomes what outcomes are associated with this program and how do they compare? Dashboard 9. Equity. Dashboard. Another important page is the Equity Dashboard. Here we combine outcome measures with institutional demographic and student characteristic data subject to appropriate privacy and governance controls. We might examine outcomes by gender, race and ethnicity, Pell status, first-generation status, adult learner status, or transfer status. This dashboard is framed around two important questions. Do outcomes differ, and where should interventions occur? That's the key. The purpose isn't simply to display differences, it's to identify where institutional policy, academic support, or career interventions may be needed. Dashboard 10, Trend Dashboard. Next is the Trend Dashboard. A single year's results can be misleading. We need to understand direction, so this page tracks measures such as employment rate, median salary, average salary, and graduate count across 5-year or 10-year periods. Now leadership can distinguish between a temporary fluctuation and a sustained trend. That is especially important for strategic planning. Dashboard 11. Cohort Dashboard. Related to trends. Is the Cohort Dashboard, instead of simply looking at calendar years, we follow graduation cohorts. For example, 2018, 2019, 2020, 2021. Then we track available outcomes such as employment, salary, employer, industry, and migration over time. This allows us to ask what happened to the class of 2020, and then how does that compare with the class of 2022? This longitudinal perspective is extremely valuable because graduate success isn't a single event. It develops over time. Dashboard 12. Institution Comparison. Dashboard for a university system, we would consider the Institution Comparison Dashboard. Essential. Instead of viewing institutions independently, put them into a common analytical framework. Compare institutions on employment, salary, graduate count, and, where available, industries and employers. Institution comparison is particularly useful in a system-level environment, but this page needs careful governance. The goal shouldn't be to create simplistic rankings. Institutions serve different populations and have different program mixes. Instead, the dashboard should help users identify patterns, differences and opportunities for deeper investigation. Dashboard 13. Major Comparison Dashboard. We can apply the same idea at the academic program level. Imagine comparing computer science versus information, systems versus cybersecurity, then compare to employment.salary, location, and employer outcomes where those measures are available. This dashboard could be useful not only for academic administrators, but also for advisors and prospective students. It helps translate degree choices into understandable outcome patterns. Dashboard 14. Career Pipeline Dashboard. Now let's make the analytics more visual. The Career Pipeline Dashboard can use a Sankey diagram. The conceptual path is student to, major to, degree to, industry to, EMP, lawyer to, salary. Instead of examining separate charts, we can visually follow the flow. Where do graduates from a particular major go? Which industries receive them? Which employers hire them? And where do their financial outcomes fall? This can become one of the most visually compelling pages in the entire application. Dashboard 15. Salary Distribution Dashboard. We would also create a separate salary distribution dashboard. Why? Because averages can be misleading. Instead of saying, the average graduate earns $75,000, show the actual distribution, less than $30,000, $30,000 to $40,000, $40,000 to $50,000, $50,000 to $60,000, $60,000 to $80,000, $80,000 to $100,000, and $100,000 or more. That distribution is explicitly recommended as a way to avoid misleading averages. This tells a much more complete story. Dashboard 16. Drill through dashboard. Now we move from summary analytics into detail, power. BI's drill-through capability is a natural fit for this application. The user could navigate institution to college to program to employer-and, where data governance and FERPA policies permit, to authorized individual-level detail. The detail page could show available fields such as employment status, employer, industry, occupation, salary, location, and graduation term. This gives us two experiences in the same application. Executives receive high-level aggregated information. Authorized analysts can investigate the underlying detail. That is much better than forcing everyone to use the same report page. Dashboard 17. AI Summary. We would add an AI summary page for executive users. This is where the application stops merely presenting charts and starts communicating insights. Instead of requiring the president or provost to interpret every visual manually, the page could summarize important findings. For example, employment increased 2.8 percentage points. Nursing has the highest placement rate. Computer science has the highest median salary. Business experienced the strongest salary growth. Healthcare remains a major employment sector. Atlanta represents a significant share of graduate employment. Those are the kinds of executive insights illustrated. The purpose isn't for AI to replace analysis. The purpose is to help leadership quickly identify what changed, what matters, and where to investigate next. How do we make all these dashboards feel like one application rather than disconnected reports? Power BI gives us the tools. Use bookmark-driven navigation to create a clean user experience. Use drill-through pages to move from institution to college to program to detail. Use dynamic titles so every page clearly communicates the current selection. Use field parameters and dynamic measure selectors so users can switch between employment rate, salary, graduate count, and other metrics without duplicating visuals. Use tooltip pages to provide additional information without cluttering the main dashboard. Use the decomposition tree to investigate outcome drivers. Use ArcGIS or Azure Maps for geographic analysis. And for enterprise deployment, use row-level security, incremental refresh, and aggregation strategies where necessary. These are all part of the proposed Power BI implementation architecture. The final product should not feel like a folder full of reports. It should feel like an application. The home page leads to executive summary.employment outcomes, salary analysis, geographic distribution, industries, employers, occupations, program outcomes, cohort trends, equity analysis. Institution comparison, major comparison. Career pipeline, AI insights, and finally, drill through. Details. Behind all of this, we would use a well-designed STAR schema, a governed KPI catalog, security designed from the beginning, and reusable page templates. These specifically keep the solution performant, consistent, secure, and extensible. The most important takeaway is this: Equifax data itself is not the dashboard, it's another source of evidence. The real value comes from connecting post-graduation outcomes with the academic information institutions already have, and then designing an analytics experience around the decisions leaders actually need to make. Done correctly, Power BI can transform that information into something much larger than an employment report. It becomes a graduate outcomes intelligence platform. Executives can understand system-level performance. Provosts and deans can evaluate programs. Institutional research can analyze long-term trends. Career services can better understand career pathways, and institutions can begin answering one of the most important questions in higher education. What happens to our students after they graduate? And perhaps an even more important question, what can we learn from those outcomes to improve the experience of the students who come next? I hope this video has given you some useful ideas for designing your own graduate outcomes analytics solution. Thank you so much for watching. If you found this video helpful, please consider liking the video, subscribing to the channel, and sharing it with others who work with Power BI, institutional research, or higher education analytics. Thanks again, and I'll see you in the next video.